we are going to see how the Okta is integrated with the for the backend. Okay, specifically, we kept our application in the Fargate, so the protection is we are giving it into the Okta, I mean API gateway. So we use Lambda authorizer when you need custom logic, you need to fine grained access control. Okta call Okta interceptor, validate the groups and then roles, support the legacy token, and then add the custom token context background. The enterprise system Lambda authorizer is still very common. So the client will call the API gateway. API gateway call the Lambda authorizer Okta validation, where either it could be allow or deny. Then it will goes to the Fargate where the Spring Boot application which is deployed, right? So what will happen is we will create a Okta auth application in the Okta admin console. We will say that application type is web or SPA. The granted type is no authorization code client credential, issuer URL client ID and then secret ID. And then we will create a Lambda authorizer function IAM role for the Lambda, AWS Lambda, basic execution role, and then Lambda authorized code Node.js is look like this. So axioms requires axioms, and then handler event data authorization replace bearer token, get the token is missing means throw the error, and then response equal to await dot axios dot post, where we are giving that URL dev-dot-okta.com auth flow, default v1 intra aspect, and then URL search param token, and then client ID is this, client secret is this, and then header is application xww form URL encoded, and then if the response is not a inactive token, and then generate the IAM policy, generate the policy response dot data dot sub allow event dot method ARN response dot data, generate policy user deny event method ARN, and then generate policy principal ID affect user resources and then context principal ID version statement. All of this it will be attached and then it will be responded. Configure the environment variable in the Lambda, like Okta client ID is this, Okta client secret is this, and we will create the Lambda authorizer in the API gateway. Type is Lambda, Lambda function is Okta authorizer, identity sources Okta authorization header, and we will say that attach the authorizer to the API route. Authorization, authorization goes to the Lambda authorizer, and then Lambda authorizer will goes to the Okta authorizer. So invalid token blocked the API gateway, valid token forwarded to the Fargate, headers passed to backend, principal ID, context sub, context scope, and then context group. Spring Boot can read them if needed. Spring Boot Fargate with what it does now was trust the API gateway, uses headers of JW to claim at request header X Amazon OIDC data, string user data, scope, role, and then request parameter. So into your explanation, in this setup, API gateway uses a Lambda authorizer to integrate with Okta. Whenever a request comes in, API gateway invokes the authorizer before routing the request to the backend. The Lambda authorizer extract the bearer token from the authorization header and validate it against Okta using the token introspection endpoint. Okta confirms whether the token is active and return user identity and scope. Based on that response, the authorizer dynamically generates the IAM policy that either allow or deny the request. If the request is denied, it never reaches to the backend service. Once the authorized API gateway forwards the request to the Spring Boot application running on the Fargate through an internal load balancer. At this point, authentication is already handled, so the backend focus purely on the business logic. This approach gives us centralized authentication, fine grained authorization, and a strong security at the API gateway layer. So shortest version API gateway uses the Lambda authorizer to validate the Okta token before forwarding request to the Spring Boot service on the Fargate. So custom logic, yes, in the Lambda authorizer, and then Okta introspection, yes, and then performance is slower, cost is higher, recommended today, sometimes. So we Lambda authorizer only when we need, custom authentication logic. So whiteboard diagram. Client is sending the bearer token to the API gateway. Lambda authorizer either it could be allow or deny. then it will allow, then it will goes to the VPC link, and then it will go to the internal ALB, and then it will go to the Fargate where the Spring Boot application is deployed. That's all. So a client bearer token API gateway lambda authorizer allow or deny, and then VPC link, அதுக்கு அடுத்தது தான் internal ALB, and then it is going to the Spring Boot Fargate. That's all.